present for the physics Chaubey, Professor Chaubey physics class. Last time we were talking about the interference and we discussed about some analytical treatment of interference. And then I told you in the end about the Young's double-slit experiment. That was to get sustained interference using one source converted into two sources. So I go further today. Further I discuss, I get more expression for the path difference, for the fringe difference, for the fringe width, etc. So that is the Young's double-slit experiment, where I have one source, one monochromatic source, maybe say sodium light. Though sodium has two wavelengths, but they are very close, so we treat them as the one. There is one source, and I have here some cardboard here, where we have two pigeon holes, and light from this passes from here and here, and this is just like two slits, you can say. So light is one source is converted now, these are two sources, you can say, and light waves coming from these two sources move forward, and say suppose I consider point P on the screen. Light waves from here, point B reaches there at point P, and from A reaches here. And these two A and B, this A and B are two sources, two coherent sources, because they are produced from one source. They have constant phase difference, they have constant frequency, etc. And these two waves meeting here, they produce interference depending upon the path difference. This is the direct distance of the source, that is the two sources and the screen, capital D. This is the central hole here, or you can say this from here. There is no hole, but this is the central line of the source. So this is the C, is the central axis, and both sides, this whole direct straight line, this is straight line. The distance from central C and Q is d by 2. C and R is also d by 2. So that Q and R, the distance between two, the distance between two sources is said d. So this d is the distance. And now capital D, I told you, is the distance between the source and the screen. And the P is the point here where we are considering the light meeting and producing interference. Now you see, we will calculate here what is the PQ. The CP is B. Suppose that CP is say X. Distance this from here. CP is say X. So what we say, we have PQ. The PQ distance will be equal to, so this is X, this is D by 2, so X minus D by 2. And PR, this R and P, PR will be equal to, say, PR will be X plus D by 2. Sorry, no capital D, small d, X plus D by 2. Now this is the triangle. You can see that in this triangle or this big triangle here, you can find out using these triangles. So using triangles, which triangles you have big triangle this here, P, B, R and PAQ. You can find out, say, the distance between, our aim is to find, what is the BP we can find out from here. We can find out BP square, this square, is PR square, this plus BR square. So BP square. Therefore, you can say this you can write further that BP square is PR square. What is PR? PR I have written here, x plus d by 2. So x plus d by 2 square plus this VR square is d square. And you can also write AP. AP square is here, that's AQ square plus PQ square. And this AQ is same as the BR is D, and PQ is say, I have written here x minus d by 2. So x minus d by 2 square plus d square. So I have now this distance, I can find out from this. First I find out, say, AP is what we have, say, we want to actually find out the path difference. So BP square. BP square minus, say, AP square. BP square minus AP square is equal to, we write the value of BP and we write the value of AP. So these are equal to d square plus x plus d by d square plus x plus d by 2 square, this thing, minus d square, and here we have plus x minus d by 2 square. So what we get from this minus, so this capital D square will get cancelled, and here you can open this and just solve this. You can write, and this BP square minus AP square, just A square minus B square is A minus B into A plus B. So this we can write BP minus AP into BP plus AP is equal to, this gets cancelled and you open the bracket, what you get here, and this x square, this minus x square will get cancelled, and 2xd xd and xd here, this minus minus plus xd, and d square by 4, d square by 4 that get cancelled because they are plus and minus. So what we get here? We get here 2xd, twice of xd by 2, twice of x, because this is x plus d by 2, x square plus d square by 4 plus twice x into d by 2. So this twice x, yes, twice, here twice xd by 2, so I do to cancel xd, here plus xd, so it becomes 2x. And what is B plus AP? BP plus AP, BP plus AP and BP minus AP, and we take as the distances, as a distance AB is small, not very small, because the two slits are not far away. So we can write approximately we can write BP plus AP is equal to BR AQ plus BR, that is equal to twice of D. So this we can take twice of D. So what we get? BP minus AP is equal to twice XD divided by twice of capital D. 2, so this is X D over D. So this is for the approximation. D is much smaller than capital D. So this is the now path difference. This is the I think I can rub this diagram. This no need of this diagram. This just I can show later on that. So this BP minus AP is the path difference. Path difference between two waves. Path difference between two waves from A and B sources, because A and B acts like two sources. So path difference is this, BP minus AP. BP minus AP is X divided 2, X divided capital D. This path, we have seen yesterday, last time, that if the path difference, we have seen for the last time for the constructive interference, for the destructive interference. For constructive interference means when maxima or peak of the other both paths are the same, so that the intensity becomes added together. Amplitude becomes A plus A, 2A, intensity becomes 4A square. So for the constructive interference, we have seen that path difference is, first we got phase difference, then path difference is twice n lambda by 2. N equal to 0, 1, 2 and so on. Means it is even multiple of lambda by 2. Means path difference, or you can say, otherwise it will be destructive. When n equal to 0, n equal to 1, so it becomes lambda, or n equal to 2, it becomes 2 lambda. So 0 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda means difference of one wavelength. So the wave starts again in the same phase. It means they are having maxima at the maximum both. So it will be maximum. So for constructive interference, or this is called brightness. For the bright, because bright means light is maximum. Maximum light. This is path difference is 2 lambda by 2. So this is the path difference. So for brightness, for bright fringes you can say, on the screen we are getting fringes, means this light bright then dark, light bright and dark. You will see alternate. So this is the bright fringes we get on the screen. You have seen last time, you have seen the screen. You will get the pattern that, so this was the screen. This was central here, C. So maxima here. Then you have dark, and then again maxima, then again maxima, then again, and both the side, maxima and dark, maxima and maxima, maxima, like this. So light here is, and then dark. So alternately maximum, maxima and minima are there. Both the sides of C, central maxima, that is the central maxima. C is the center maxima. So both the sides of C we have dark, bright, dark, bright, dark, bright. These are called fringes. So fringes are there. For the bright fringes what we get, it should be 2n lambda by 2. So xd over d must be 2n lambda by 2. What we get from this? For the bright fringes, we get that x is equal to this d, or x is equal to d by d and lambda, and this 2 cancels, so n lambda and d by d, n equal to 0, 1, 2, so on. So this we get. For the bright fringes, the distance must be, for the bright fringes, the path difference must be, say, x must be n lambda d by 2. So for the first bright, for the first, from the center, for the first bright fringe, what we get for the first bright fringe? That is, we write x1. Path difference for the two waves from BP and AP. Path difference is how much? For x1, this is the x1 is lambda d by d. For second bright fringe, we have x2 is equal to here, x2, n equal to 2. So 2 lambda d by d. Like this, you can have several different, for n bright fringe, it should be xn equal to n lambda d by d. So this way what we get, the difference between the nearby two bright fringes, that is called the fringe width. Difference between two nearby bright fringes. What do we get? That means xn minus 1 or equal to x2 minus x1. So that will be distance between this x2 minus, and this is called beta, fringe width. This is called fringe width, beta. So beta is equal to the difference of this 2 lambda d by d minus lambda d by d. So lambda d by d. This is the fringe width. So bright fringes are separated by this distance. You can say path difference is there. So fringes are separated by this. So beta is equal to x d by d. So means fringes are separated, bright fringes, by lambda d by d, beta distance. Now we go to the dark fringes. For dark fringes, we write the path difference. The path difference is for the dark fringes. The path difference we have earlier for the bright fringes. Here what we will have? Beta is equal to x2 minus, first we should write for the dark fringes we should write the expression. What is that? For the dark fringes we what is the path difference? So first we write path difference. Path difference is, say, what the path difference? That is a x d over d. X d over d. That is a 2. Path difference, say, x d over d. X d over d. If this is 2n minus 1 lambda by 2, we get minima or dark. Dark means the maximum of one wave falls at the minima of the other. So that means the odd, it should be odd multiple of lambda by 2. While for the bright fringes we have the path difference is the, that is, you can see that here one wave like this starts, second wave also starts here. That was the maxima, bright. For the dark, what we see that this is a one wave, and other wave, this is starting here, but other wave is starting like this, or starting from here. So the path difference is now not the integer multiple of lambda, but odd. So it is because it should be odd multiple of wavelength. So from here, it should not start. It should start here, but like this. So that both the waves are just. Just opposite means maxima of 1. So path difference is lambda by 2, or it starts here. This is going here. So it should be odd multiple of lambda by 2. Means 1 lambda by 2, or 3 lambda by 2, or 5 lambda by 2, like that. So it is just maxima is opposing. So that means n equal to 0, you can say. So that you can find out for x1, you put n here, 1. So 2 minus 1, it is lambda by 2. X1, yeah, so x1 means, sorry, this I should write x. First, x is equal to 2n minus 1 lambda by 2, and then d over d. So what is x1? x1 is 2n, 2 minus 1, so 1 lambda by 2 and d over d. Like this you can get the values for x1, x2 or xn for the dark fringes also. x2 is equal to n equal to 2 to 4 minus 1, 3 lambda by 2, 3 lambda by 2 and d over d, and so on you can write. So that xn is equal to 2n minus 1 lambda by 2 and d over d. So beta is equal to x2 minus x1 is equal to, you find out this difference of this x2 minus x1, 3 lambda by 2 minus lambda by 2. So 2 lambda by 2, 2 to cancel, so lambda d over d. So fringe width, what do we get? For the dark fringe also, the difference is same, beta is same for both. This means bright fringes and dark fringes are of equal width. Means this separation, black and white, black and white, black and white, all are equally separated. So all the fringes all the fringes are equally separated. This means that the fringe distance is constant. So fringe distance is constant. Fringe distance is constant. That is a beta is equal to lambda d by d. So we can design an experiment. This is now analytical method. We get fringe width, lambda d by d. We can design an experiment in a dark room, keeping one sodium source. You produce two sources. Simplest method was given by Young's double slit, that Young designed two slits from one source, making two pigeonholes in a cardboard or in the slit make, so that the two sources are now coherent because they are made from same source. They have constant phase difference, they have constant frequency, constant wavelength, etc. It is not changing. So one source producing two coherent sources. Otherwise, it is very difficult to have two coherent sources. So two coherent sources interfering, and on the screen like this, they are making bright and dark fringes. And you can find out, you can measure this beta by using some micrometer telescopic arrangement you can get. Microscopic you can put very close and you can get the distance between. So using a small eyepiece you can say, not even microscope, eyepiece you can read the distance, you can measure the beta is measured, lambda and d is known, and d is also known because we know the distance between two slits. So lambda is measured, lambda is calculated. If lambda is known, then beta can be calculated, fringe width can be calculated. So this method, interference, designed by say Young, this was very simple as possible. Then there are methods to produce two sources. There are methods, I don't want to go to details of this, methods to produce two coherent sources So you can use some methods to produce two sources, just like we have Young's experiment, where Young designed two slits or two sources for one source, so it became coherent source. You can use some method. There you will see the books. There is Lloyd's single mirror. And there very good experiment is, which is done in the higher classes, in the BSc laboratories, that is the Fresnel's biprism. The Fresnel biprism is a method to produce two coherent sources using two prisms, small, very thin prisms joined base to base. So I am not going to discuss, because those are the methods to get two coherent sources from one source. But basically what we want to get two coherent sources of monochromatic light, one light. So that is the using one source and then Fresnel biprism. Biprism is simply say two prisms joined base to base here. This one prism and another prism, a light coming from here. So this light falling there. This produces two sources, going on that side and going on this side. So this light comes here. It looks like this source has got two sources, S1 and S2, and this is the S, separated by some distance. With this, the light deviates and this comes to the back side. This light here deviates and this comes here, as if this light. So this back side here, they produce two, one source by the, so this biprism is called Fresnel's biprism because Fresnel designed such that base to base is joined, so this light going from here appears to be coming from this light appears to be coming from this. So one source converted into two sources. So this is a method of getting two sources, coherent sources. Otherwise, what is the analytical treatment done in the young slit experiment is same. So you get beta. Beta is the fringe bit, that is the important. Beta is equal to lambda d over d. This is the important for expression. Using this expression, we can get lambda or we can get beta out of the 4 parameters. If 3 are known, 4 can be also calculated. So this gives us very good experimental method for measuring the wavelength of light source. So friends, I will stop here, and when we meet tomorrow, we will discuss further using this formula. We will we will solve some numerical problems, or we discuss some short answer questions, multiple questions based on the interference knowledge. So we stop at this place. Thank you very much.